Greetings, this is Jim Lindsay. This is a lesson about material from Chapter 12 in your textbook. We're going to be talking about databases. And if you look on the Blackboard site, you'll see that there is a PowerPoint presentation that you can print out, and in it are some slides that I think may help you learn this material. So I wanted to encourage you to download that, print those out, and they look like this, of course. If you go to File and then to Print, you can jump into what would you like. You can jump into Handouts here, and you can print out basically handouts on which you can then start to take notes. And so I wanted to make sure you are aware these are there, and let's get into the material. I like to begin this lesson by basically, I've not taught this one online. I've not taught this a database class in CIS 141 online ever. I've taught database classes, like entire semesters devoted to databases at the 400 level in our CIT program, but I've never taught it online at a 100 level. And so the way I approach this in the classroom is the following. Basically, I start by presenting the class with a graphic. Say, hey, look at this, old school file cabinet, and what I'd like to do is present you with a list of questions that I'd like for you to answer, using this old school file cabinet. So you have an XYZ company, which we're going to pretend that XYZ makes boats. So they make jet skis, boats, any kind of watercraft that you might want to have fun with at the lake. XYZ makes it. And in this filing cabinet, it's about a 6 foot tall file cabinet. It has 4 drawers. You see these pretty frequently when you go to any kind of office setting. There's the one drawer for sales information, another for personnel, another for inventory data, as well as on the bottom shelf you have stuff about accounting and finance. And so the first question I'd ask the class to answer is, say, okay, here's your first question. If you had to figure out the total sales of motorboats in May of 2015, how would you do that? And say, hey, talk to the person next to you, and after about 30 seconds, a minute, I'll call on a couple of people, and I say, well, we'd go to like the sales drawer, we'd pull that out, we'd find our way to May 2015, look for the data, and then compile that and basically come up with that total sales figure. Great, that's I agree, that's how I would do it too. And then we start to progress and get more complicated questions, like this next iteration of it is basically, let's look for total motorboat sales in 2016 October, and then on top of that I need to know which boats were sold by which salespeople and their social security numbers. And so as you start to answer this question, you have to pull out additional files from additional drawers and start to compile, okay, here's the social security number for John Doe, for Susie Q, and start to, put all this information together. We'll take it even a step further. We'll go to, let's go one more actually. Let's go right here. So then we'll add which models were back ordered in the month of, say, January 2017, in addition to the social security number data and so on. And so at that point, you're starting to dig into 3 if not 4 of the drawers, and then we start to think about, okay, well, what kind of time frame are we talking about to answer this one question? And it could take anywhere from 20 minutes, 30 minutes to answer one question, right? And so then I basically say to them, okay, wouldn't it be great if there was a tool available where you could answer like all these questions readily within just seconds? All you have to do is just click on what the different things you would like to answer, hit go, and then it comes up with the answers to the questions you're looking for. And of course everybody goes, yeah, that'd be great. And they go, well, great, that's what we're talking about today, because we're talking about databases. And databases are, as you look in your book, and this comes from page, as you look in your book, 479 in the 16th edition of the book. 479 is where this chapter starts. It's talking about a database. Basically is this collection of related tables of data, and this database management system basically allows you to go through and create those queries, ask those questions that we just were asking, and then generate reports with from the queries in a usable fashion. And so that's what we're talking about. And so I love this exercise of basically going through, pretending we have the file cabinet, and then going to this electronic version, saying, okay, well, great, this is why we have this. And to further emphasize the point of how important this is, any website that you go to nowadays that you guys enjoy, any of the social media websites, Twitter or even Facebook, if you want to go old school, Amazon, Netflix, all of that stuff is database driven, because when you open up Netflix and you want to open up all the different episodes of all the different seasons of your favorite show, what you're doing is you're creating a query. You're asking questions of the database management system that's at Netflix, and then what it does, it pulls up all those available episodes, and then it starts to stream those out to you. And so you use this technology every single time you're getting on the internet and you're interacting with websites. Here at WKU, TopNet is a database-driven website. So is Blackboard. This is a very highly used technology. If this interests you at all, I very much encourage you to pursue this, because this is a wonderful job opportunity. If you become a database worker, I don't think you'll ever run out of work in your lifetime. I mean, it's just as much stuff is database driven nowadays. I think you're forever going to have a job if you go into database work. And so that's what we're talking about. That's why we're talking about it. Now let's look at some of the details about what makes a database work. Okay, there are some key terms I want to make sure you are familiar with, and you're not going to know what these mean yet, and you're not going to be able to put these into context until a little bit later, but you need to start hearing these terms, because in a separate lesson, basically I'm going to show you how to build a table of a database, link tables, create a query, and in doing that, basically by doing the hands-on part, in addition to hearing about it here and having read about it in your textbook, it'll start to make a tremendous amount of sense. If all you do is just read the textbook and listen to this part, it's still going to be really nebulous. I mean, the way to get a much better grasp on what this stuff is to actually do it. It's almost like if all you ever did was read about basketball, and you maybe watched a basketball game on television, but you never went out in your driveway and shot free throws. I mean, you never have an idea of like what it's like to dribble or try and shoot around somebody or block somebody. And so that hands-on portion is really helpful in getting this kind of topic. I hope you will take advantage of the hands-on part that will also be available. The terms I want to introduce you to right now are basically the following. We have fields, records, tables, and all of those go together to create a database. And that's going to create our hierarchy of data, and you'll see that mentioned a little bit later in the chapter as well. And where I'm working from is basically pages 479 through about 481 in this very beginning of the chapter. And if we were to think of Excel, you guys are familiar with Excel from your SAM work. A single column within an Excel spreadsheet would be a field. So if you're keeping track of WKU student information, a student's WKU ID number would be an example of a category. Of a field, of a column. And so another thing you might keep track of is their last name. That would be another column. Maybe their first name. That would be another column. So each one of these columns within the spreadsheet would be what we call a field. Similarly, if you go to the rows, like you take a collection of all the related fields, so you take a row, that's called a record. So we have fields and records, and if you combine all those records together, then you get a table. And again, I know this is kind of like, what the heck is he talking about? When you see the hands-on part, it'll start to make more sense. But fields, records, and tables, and all of those, all the tables combined to make databases, that's your hierarchy of data. Now, another thing it gets into, it starts talking about something called a primary key. One of these fields within a table is one that we call the primary key. Or if there's not a single column which will uniquely identify something, you can take two or more and combine those to create something unique, and that can serve as a composite primary key. But one of those fields is going to be something we call a primary key. Let me give you an example of that. This graphic right here, we'll come back to that in just a moment. But this primary key is basically one of those fields that will uniquely identify every single thing within that table that it's in. So for example, let's say we're keeping track of WKU students. Well, what is something about WKU students that's unique? Well, you have your WKU ID number, right? You have your 800 number. Also, your email address is unique to you. Also, your net ID is unique to you. So any of those three things would be really good primary keys if we had a table of WKU student data. So that's what a primary key is. This preceding slide here we looked at a second ago, this comes from your book. It looks on page 480 if you were to look at that. That is a similar example. Like in this one, the author basically is talking about a ski boot rental place, or like a ski and ski boot rental place, that just like I was using the file cabinet example with the XYZ company. So this is just another example for you, and the things they describe in these pages, talking about ways that a database management system can help a company basically answer questions, quickly. And that's the goal. The reason we have a database management system is to keep track of data accurately, and if we're keeping track of data accurately, on top of knowing the data about our organization or about our company, we can also ask questions and answer questions accurately, and so that's tremendously valuable. So that's the first part of this chapter, essentially trying to explain what a database is, why it's valuable, these really foundational terms of fields and records, and putting those all together in tables, and so that's our initial chunk of this chapter. Okay, so you know what a database is. Now let's look at who makes databases, because the next thing I want you to look at, and as you look in your chapter, if you look on page 482. On page 482, it introduces you to 4 different people. It talks to you about database designers, database developers, database administrators, and users. It introduces you to 4 different people. And again, it's talking to you about designers, developers, administrators, and your users. Now, what makes this sort of difficult when you're learning this, especially from you're first introduced to it in this chapter, is that there are lots of synonyms. So in addition to being called a database designer, sometimes these people are also called architects or engineers or analysts. It's all the same thing. Those are all synonyms for basically the person that comes up with the design for the database. And then it talks about the people who actually build it, your developers. Now, in addition to developers that build the database, there are often people called programmers, database programmers, and they typically work with the web side of a database. So think of the Amazon.com example we talked about earlier, where you have a database that's basically keeping track of what products Amazon has to sell. In addition to the database of what's their information, they also need people that can create the web pages and write the scripts that are going to basically take the data from the web pages and put the information into the database, and get the database and extract the information out of the database and put it back into a web page that people can look at. That's what your database programmers do. And so these two guys right here, they kind of work, it's a really small company, that could be the same person. At a bigger place like WKU, that's going to be two different people or two different teams of people that are working on, those kinds of projects. Your database administrators, those are the people that once something is built and put together, they basically maintain it. They are responsible for its security. They're responsible for making sure that everything that's inside of it is accurate. And then lastly, you have this group of people called users that just use the database. And so think of TopNet as an example. You and I are users of TopNet. I get in there and I look for my class rosters. I look for your email addresses so I can send you guys correspondence, whereas you guys get into TopNet and register for classes. I mean, we're all users of that system, but none of us thought it up, none of us built it, none of us take care of it. We just use it. And so these are four different users, four different people, actually five different types of jobs that work with databases. There's I think a really helpful metaphor in understanding what these people do. And just go with me on this. I know this is kind of weird, but think of like an apartment complex. Let's say you were a real estate mogul and you wanted to create an apartment complex next to Western Kentucky University. What you would do is once you had gotten a piece of property, and you basically had bought some land, at the point when you want to start to create your apartment complex, the first thing you would do would be to enlist the help of somebody that would help you come up with a set of plans for that apartment complex. You'd look for an architect, right? And one of your synonyms for designers, database designers, is database architect. And so what this architect does is they basically think up in the database world, they think of the different database components that need to be there in order for this thing to actually work. This database analyst or database architect or database designer, all these synonyms here, this is a really great opportunity for business graduates. If you come out of business school and you get a little bit of additional database training, this can be a really cool job for you, because what you have some business acumen, because you've taken accounting and finance and management classes and some IT classes, and you can speak business, and at the same time you've had this additional database training, so you can also speak database. And you go out and you talk to the business units and you find out, hey, we need a database that will do this, this, and this for our department, for the accounting department. And so then after you discuss with them, you go back to the actual builders, the developers and the programmers, and you explain what it is in terms that they can understand. You explain what it is that people at the accounting department want from their database. And so you work as the bridge, that these database designers work, or architects work as a bridge between the business units and the people that actually put them together, or actually build those in like Oracle or MySQL. And so this is a pretty cool job opportunity for business graduates coming out that are interested in database, but maybe are not don't want to be an actual database developer or administrator. This is a great way to kind of get your feet wet in that database world. Your database developers and programmers, let's continue with that whole apartment complex metaphor. These are the carpenters and the electricians and the people that would actually build the apartment. So that the database designer or architect, that's the person that dreams up what the place should look like. They draw the blueprint for it, for the apartment complex. And then the database developers and programmers, those in the apartment metaphor, these are the people that actually would build the building. And in the database world, these are the people that actually would get into the software like Oracle or MySQL and actually create the tables and link the tables and create the queries and get all that set up and then populate it with data for that has been thought up by the designer. The next person is the database administrator. In the apartment metaphor, what a database administrator would do, they would be the person that runs the apartment complex. So think of like the landlords or the people that you would go to sign a lease or terminate a lease, or if your washer broke or something, or your heating unit wasn't working correctly, you'd go talk to the people to basically fix it. That's what your database administrators do in the database world. They make sure that the database is functioning properly, that it's secure, and they take care of it. Now, lastly, you have the users. In the apartment metaphor, these are the people that would live in the apartment complex. These are the ones that use it, that live there. And in the database world, these are the people that would use the database once it's been created. So hopefully that helps. I wanted to show you a website. Let me jump over to my browser real quickly. I wanted to show you something about these people. Okay, I'm at a website called Indeed.com. You've probably heard of this, Indeed.com. This is a job searching website. And what I did, I just put in database administrator. I'm in Bowling Green, Kentucky, so it automatically populated the location up here. I hit find jobs, and what it's showing me is just basically different opportunities in this area for this type of position. You'll see there's salary estimates over here, 4 at 55,000, 3 at 80,000, and so on, one all the way up at 90,000. These are, and those are estimates right there. But as you click on the one at Camping World, for example, this is a database administrator job. This is with Oracle. That's a type of software for databases. You can read about the company itself in the job description. What I'd like for you to see is basically this is a really good job, and this is a hard job. Don't get me wrong. The stress that goes along with being a database administrator is immense. Think about if you worked at Amazon.com and all of a sudden the website didn't work anymore. Can Amazon make any money if the database or the website's not working? No, they cannot. And all of a sudden, your whatever you were doing with your home life, it's on hold until that is fixed. It's a high stress job. But the rewards for it are also really high too. And so, if you like this sort of technology, if this piques your interest at all, I encourage you to contact me, because I'd love to talk to you about it. I think it's a great area to work in. And if you looked at Louisville or Nashville, you would see many more opportunities. I mean, it's just this is a type of job that I feel really great recommending to students, and I hope you guys will be interested in it. So if you want to learn more, let me know. But these are the people that create those. These are the people that create and use databases. So this is talked about in the book, and I want to make sure we spend some time on it. Okay, let's move on. Next, what I want to talk to you about, if you turn back to page 485 in the chapter, it starts. It basically restates that data hierarchy, which I've already mentioned to you. Where we have fields, records, and then tables, and then finally a database, and how these all are related to one another. Once you get to the hands-on part, that again will become much more concrete in your mind. So this on page 485 is basically sort of re-emphasized, and then next it gets into this idea of entities. And basically, when you have a database, you're keeping track of different things. And the different things which you are keeping track of are what you call entities. And the reason I want to bring this up is because relationships exist between these entities. And so as you look at page 485 and 486, it talks about various relationships which can be created within the database management system. And those relationships can be one-to-one, one-to-many, or many-to-many. And again, at this point, I know this is like, what is he talking about? Well, I want to show you. From a case. I want to switch over to Microsoft Access, which is a database management system, and actually show this to you and make this make more sense. But again, what we're talking about, different things that you're trying to keep track of in your database are called entities, and typically each different entity is going to become a table, and so those tables can then be related to one another in different types of relationships, and those are going to be of a one-to-one, one-to-many, or many-to-many type. And so let me show you what that looks like. I'm going to jump over to a database program. Okay, I am in a program called Microsoft Access, and you'll see this in the hands-on portion. Hopefully you will do it. Hopefully you will you take advantage of this opportunity. But what this, if you do, you're going to basically be working with this database. And this is a database for a rafting guide company. Think of like if, let's say, your family was going to go on vacation and you wanted to go rafting, or you wanted to go out and do hiking or some sort of extreme outdoor kind of activity. Well, you typically aren't going to just go out to the Grand Canyon and just throw a boat on your car and just try it yourself. You're going to find somebody that knows what they're doing to lead you through that exercise, right? So that's what this company does. And in this project, what you do is you create different tables. These basically become entities in this database. And what this company's database keeps track of, it keeps track of trips that people might go on. And the people that would lead those trips would be the guides. And so this table right here is linked to this table over here. Likewise, when customers call and they make a reservation or get on a website and make a reservation, that's another entity, and that's a table over here. This is one of the table that you will create in the exercise itself, and this is you'll see that they're keeping track of which states their trips take place in, and so this is a really easy table to make. So this is the one that we will make in that hands-on exercise. So these are different entities, and let's look at some of these relationships, because where you see a line connecting one table to another table, or one entity to another entity, these are relationships. And you'll see that at the end of the line there's either a 1 or an infinity sign. And if you'll think of back to your math days, that symbol that looks like a number 8 turned on its side, that's the infinity sign. So these are one-to-many relationships. The 1 is over here in this case, and the many is over here because the infinity sign is over here. And what this means is that for each trip there is just one guide, but for each guide, each guide might lead many different trips. So for example, let's say we have a guide named Tommy. Well, Tommy might lead trips in the Grand Canyon, or he might lead trips at Mammoth Cave, or he might lead trips at Yosemite Park. This one guide can lead many trips, but when you go on a trip, there's just going to be one guide. Likewise over here, when you go on a trip is only going to have, for each trip, there could be many different reservations, right? Because you're probably not going to do a trip for just one person. So for that one trip, you could have 10 different people on it. But for the reservations, there's just a single trip for which that reservation has been made. And so those are examples of, when you look at the relationship chart in a database management system, hopefully that's going to make that a little bit more concrete for you when you're learning about the different entities and there's relationships which may exist between them. Okay, now what I'd like to do, I'd like to jump back in the chapter all the way back to page 494 and just cover a little snippet out of the back part of this, and then that will be it for this this tutorial right here. In the hands-on part, I will refer back to the book, back to these pages that we've skipped, or some of the pages that we've skipped, to talk about like data definitions and the data dictionary. But for right now, I want to jump back to page 494, and this is just some real straightforward stuff. Basically, as you read through these pages here, it says, hey, a database can basically be like a single user database, or it can be a multi-user database, and that's exactly what it sounds like. You can have a database like the one that we're going to use, where only one person at a time is in there working with it. If it's for a small business or like even a medium-sized business, that's probably going to be sufficient. But if you get to something like WKU, where you have thousands and thousands of users, you need a multi-user database system. And in those types of systems, they're much more complex. And so that's the first thing they throw at you in this section of the text, to say basically single user, a multi-user. Now with the multi-user, basically those are probably going to be client-server database systems is how those are going to function. And what that means is that basically one computer is going to act as the server, as the database server, and then the other computers are going to, the clients are going to interact through the computer network with that database server. Now once you've been through chapter 7 and 8 in the textbook, that should make sense. Basically, you know what a server is. It's a computer which basically provides a service to others through a computer network. That's what we're talking about here. So your multi-user database systems basically are client-server types of software. Now there's one more twist to this, and basically if it's a really big organization, what you might also experience is you might work with something called an N-tiered database system. And so think about if you've ever had like a research class where you talk about where you went out and you got basically a bunch of data, right? Your sample size is referred to the number, my N, basically my sample size is so big. That's where they're talking about N-tier systems, like how much separation is there between the clients and the server. With your N-tiered system, there's at least one layer of separation, and in that separation is software we call middleware. That's as far as I want to take it with this class. And like in that 400 level class I taught, this is where we were working at that middle layer quite a lot. But for CIS 141, if you will basically remember, hey, we can have single user systems and multi-user systems, and the multi-user systems are basically client-server based systems. And sometimes if it's a pretty big organization, between the client and the server you can actually have like middle stuff, and those are your N-tiered systems. That would be great. I would be happy if you would know that. That would be awesome. If you pursue this as a profession, you can get into the details of this in much more depth, but I think that's sufficient for right now. All right, cool. So the next idea they get into, this one is a pretty simple idea too. It basically says that you can have a centralized database or you can have distributed databases. And what that means is basically again, we're talking about a client-server based system here at this point, but with a centralized database setup, the entire database server is all at one spot. And there's like a single computer on which all those, all the database stuff is stored. In contrast to that, let's say you have like a national company and part of the stuff took place in the western United States and part of the other activity took place in the eastern United States. So let's say manufacturing is over on the western side of the country and sales is taking place on the eastern side of the country. Well, the place where you actually put the database servers might be literally some of it over in California and some of it over in New York State. And what you do, the reason you do that is that the servers are physically closer, probably in the same building as the manufacturing people, and then physically in the same buildings in New York with the sales people. And because it's closer, because that's the data they're going to be working with most of the time, their queries run faster and basically they can get to it quicker. Here's a graphic which shows that same sort of thing. You basically put the machines to the people that are going to use them the most. Now, through the network, can the manufacturing guys still get sales data from the New York servers? Well, sure they can. It's just going to take a little bit longer because it has to go through the internet to get there and back, but they can still get that data. So you can have centralized or you can have distributed databases. Okay, and to close this lesson, basically there's one last type of database setup that is presented to you, and they talk about disk-based systems, they talk about in-memory systems. And these are really cool. Your disk-based systems are the traditional ones like what we're working with. There is a file stored on the hard drive of the machine that you're working on, and as you need, as you perform a query, it's going to basically reach out to the data stored on the hard drive and pull it, and then pull it into memory, and then use it as it needs it. But basically, it's operating off of the hard drive. In contrast to that, if you need like a really high performance sort of database, because memory has gotten as cheap as it has, and because you can now put so much memory in computers compared to even 20 years ago, now there are in-memory databases. And what that means is that when the program starts, it pulls everything into memory, and the whole thing exists just in memory. And so because it's just in memory and not having to go up to the hard drive, it works really, really fast. And that's great. That's awesome. The drawback of that is that if you lose power, because memory or RAM, memory and RAM are the same thing. If you lose power and the database it's only stored in memory, if you lose that power, then you're going to lose everything. And so the backing up of your data, the importance of it just exponentially goes up if you're using like in-memory sorts of databases, because if there's any sort of failure, the consequences of that could be devastating, as opposed to with a disk-based system, if the power goes out, man, it's a bummer, you've got to reboot everything, but everything was stored on the hard drive anyway. So that's presented to you, and that's the last idea from the and that this is presented to you on like page 496 in the chapter. There are some more ideas on page like 497 and the subsequent pages I'm going to again refer to when I do the hands-on part. But these are hopefully some ideas that have resonated with you, that have piqued your interest, and I hope you're going to want to learn more about this. Please do the hands-on part as well as you can, because it will enforce this stuff very much. So thanks for your time and attention.